Dear students, we are going to teach the lesson number 4, shortcuts. Okay, the part 4, shortcuts. Okay, thank you for giving your response. Okay, and these are very useful to solve the problems very easily. All of you follow my class. Okay, without fail, all of you listen. Now, suppose x power n into sin ax or x power n into cos ax. This type of pattern problems are there. How can we solve this type of problems? Very easily and effectively we can do within the 1 or 2 steps only. Okay, they follow the pattern. Suppose x power n is there, sin ax is there, minus plus plus minus minus plus plus like that. Here also we have to follow this one, you have to close this one, same pattern. First minus you close, same pattern we will. Okay, this one easily you can remember. Here cos is there, plus plus minus minus plus plus and so on. Like that it will be followed. Okay, and you see, if you take one example, and x square sin x suppose is there, sin x dx. How can we do this one? You see, that's it, first pattern. Okay, and it is the same pattern we are following, and x square, first you have to write the x square, and x square derivative 2x, you have to give the gap and write 2x, and you have to give the little bit gap, 2x derivative 2. And what is the pattern we are going to follow? Sin x is there, sin x, this pattern, this one is same as this one, minus plus, 3 terms are there. 3 terms, first term minus, second term plus, third term plus. We have to follow that one. Minus, plus, plus. Okay, clear? And now we are going to write the sin x. Sin x becomes cos x becomes sin x, sin cos like that. It will be repeating. And sin x becomes cos x, and cos x becomes sin x, and sin x again it will be cos x. And one more thing, 2 derivative again 0, no need to write that one, 0 into sin x, that is 0 only. That's why we are not writing plus. This is the final answer, very easy to get this one. And if you take cos x common also, 2 minus x square cos x, according to the answer we can do that one. Okay, and one more, the second one, x square into cos x is there. How can we do this one? Cos x is there, the second pattern. How can we do this one? See, x square, again you have to write the same pattern, x square, first one, and x square derivative 2x, give the gap, and 2x derivative 2. Okay, now clear? Now we are going to, it is the before writing cos and sin like that, before writing this one, signs are there. This is this pattern. You remember this pattern. If you remember this pattern, easily you can do this one. Okay, this pattern. Here plus minus, 3 terms are there, na? First 3 signs, plus minus. Clear? And one more, it is very easy to write this one. Cos becomes sin, sin becomes cos, and cos becomes sin, and it is finished. Plus is constant of integration, you know very well that one. This is the very easy method. And sir, suppose sin ax is there, sir, here ax or 2x is there, cos 2x is there, sin 3x is there. How can we do this, sir? That type of also we can do easily. See, integration of x square into sin 2x, suppose it is there. How can you do this one? X square into sin 2x. The same pattern we have to follow. Very easy. X square, first you have to write the x square derivative 2x, 2x derivative 2. The same pattern. Sin 2x is there in this one, the first pattern. Here minus plus 3 terms. Minus plus. Clear? And now sin 2x becomes cos. You know, cos 2x, and cos 2x sin 2x cos 2x. Okay, and plus c, and it is not finished. Still it is there. Here coefficient is there. What is the x coefficient is there? Angle. What is the coefficient in the angle? X coefficient in the angle. Here x coefficient is 2. That's why it is 2. It is 2 square. It is 2 cube. Like that. You can write. Suppose it is a is there here. A is there. X is there. By a square, by a cube. Okay, this type of problems reflected in the exams also, previous exams also you can see. Cos 2x by 2. Okay, plus x sin 2x by 2, and 2 gets cancelled. Cos 2x by 4 plus c. This is the final answer. You can simplify it according to the answer. Okay, and one more shortcut. Suppose integral of x cube sin x by 2 is there. Suppose sin x by 2 dx. This type of problem, how can we do this one? X cube, it is x coefficient is 1 by 2 here. X coefficient is 1 by 2 here. X cube is there. How can we follow? X cube next to 3x square. X cube derivative 3x square. 3x square derivative 6x. 6x derivative 6. Okay, we need to write this one. And this is a sin x power n sin x power sin n. This one only. A is what? What is a here? X coefficient is 1 by 2 here. Remember that one. That is very important. Here the 4 terms are there. Minus plus plus minus. Minus plus plus minus. Isn't it? Minus 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 plus plus minus here. Here now the sign becomes cos x by 2. Here sin x by 2. Here cos x by 2. Here sin x by 2. It is finished. And not yet finished. Here a is there 1 by 2 here. Here 1 by 2. Here 1 by 2 whole square. Here 1 by 2 whole cube. Here 1 by 2 whole power 4. First one is whole power 1, whole power 2, whole power 3, whole power 4. 4 terms are there. No? You have to write like this. It will come up here minus 2x cube cos x by 2. That is the first term. And it is 1 by 4. It multiplies 3. And 12x square sin x by 2. And it is 8. 8 into 6. 48 cos x by 2. Okay. Minus 96 sin x by 2. And it's plus c. Okay. These are 8 na? 8 6 48. 16 6 96. Like that. Okay. It is very easy to solve this type of problems if you use this shortcut, this pattern. Okay. Very easy. You can do this type of problems, I think. Okay. And suppose x square cos 2x is there. How can you do? X square cos 2x. Okay. You try x cube cos 3x is there. X by 3 is there. How can we do this one also? You try. This one also you can try. Okay. Very easy and very useful shortcuts. Okay. And dear students, if you need more shortcuts and the guidance from my side, feel free to dial and contact me. Thank you so much for watching.